let's look at how you can add rational expressions that don't have a common denominator. So here's an example, 4 over 2y plus 9 over 3y. Now to start this problem, I'm going to go back to an elementary arithmetic problem. Let me turn back a few pages. And if you could just recall how we added something like in this green cloud here, 2 over 7 plus 3 over 7. Do you remember that this denominator, the 7, describes the size of each piece? So when we write the fraction 2 over 7, it means we have 2 pieces, so the quantity is 2. 2 pieces that are each a size 1/7 of a whole. So we've got a whole cut into 7 pieces, and this pink 2 means we have 2 of them. We're going to add that to 3 pieces, a quantity of 3, out of a whole that's been cut into 7 pieces. So 3 pieces that are 1/7 in size. When we added this, we got 2 plus 3 over 7, or 5 over 7. Now in this example that we're going to start with today, we've got unlike denominators. So the review problem for unlike denominators is like this blue cloud, this 2 over 3 plus 1 over 5. Do you recall that the first step is that we needed to find the common denominator? The least common denominator is going to make this problem the least trouble. So we're going to use 15. And then what we did to 15, we got the least common denominator, 15. Next, we rewrite the 2 over 3 with that denominator of 15 and write 1/5 as a denominator of 15. So to do that, if you recall, we would say 15 divided by 3 is 5. 5 times 2 is 10. Or in other words, we're looking for, what do I multiply the 3 times to get the 15? And do the same thing to the numerator. So that's where we get a 10 over 15. 15 divided by 5 is 3. 3 times 1 is 3. Or in other words, we were noticing that to get the 15, we multiplied 5 by 3. So multiply the top by 3 also. Once we have the 10 fifteenths and the 3 fifteenths, we add 10 pieces plus 3 pieces to get 13 pieces. And the size of the pieces stays the same, this 15. So that's an arithmetic review. Let's carry that over to our algebra problem. We're going to use the same process. We're going to find the least common denominator, and then we're going to rewrite each fraction with the least common denominator, and then we're going to add. So if we have a 2y and a 3y, we could look at the factors of 2 and y, and look at the factors of 3 and y, and we see that the least common denominator is going to need a 2. We'll only need one y and a 3. So the least common denominator will be 2 times 3, or 6, y. What does that do to our fractions? If we wanted to change 2y into 6y, what we do is we notice, well, we already had a 2 and a y. What we need to insert is a 3. We already had a 2 and a y. We needed a 3. So we're going to multiply that 2y by 3. To keep these fractions equivalent, whatever I do to the denominator also has to be done to the numerator. So I'll also multiply the numerator by a positive 3. For 3y, we already have a 3 and a y. If we want to make that a 6y, we need to multiply it by a 2. 3y times 2 gives us our common denominator of 6y. If I multiply the denominator by 2, I'll need to multiply the numerator by 2. And now I'm ready to add. We have a 6y in the denominator. So when I add these, 6y stays in the denominator. In the numerator, we've got 4 times 3 plus 9 times 2, or in other words, 30 over 6y. We're almost done now. Before I box that answer, I'm going to notice that I need to reduce or simplify. Because 6 goes into both a 30 and a 6, I could reduce this by 6. 30 divided by 6 is 5. 6 divided by 6 is 1. So our final answer is 5 over y. We reduce the 6 and the 6 to get 5 over y. Let's look at another example where the denominator is maybe a little more complicated. This is an important pattern to recognize. It's important to notice that 9 minus x squared and x squared minus 9 are opposites of one another. Let me say that again. 9 minus x squared and x squared minus 9 are opposites of one another. So I can simply rewrite this 9 minus x squared as the opposite of x squared minus 9. And for this special problem, now all I need to do is undo this subtraction. So what I'm officially going to do is I'm going to multiply by -1. So I get minus -8, which turns to a plus 8. But that could seem a little complicated. So I'm going to show you a better way to maybe write that. When we have minus a negative, they undo each other and become positive. Two negatives cancel one another out to be positive. So now we have common denominator of x squared minus 9 and the numerator of 3 plus 8, or 11. And there's nothing to simplify, so we're done with that one. We can box it. Let's look at one more example where it's maybe a little more complicated. What I've already done is factored each of the denominators. Now we want to, 1, get the common denominator. You could see that to have the common denominator, we're going to need an x minus 8, an x plus 7, an x plus 7, and an x minus 3. So let me simplify that for you. Let me simplify the process for you. You look here at this first denominator and see, what does the second denominator have that the first one doesn't have? And do you recognize that this one has the x minus 3? The second fraction has an x minus 3. So in order for these two to be identical, to be the same, I'm going to need to insert a factor of x minus 3 into this first fraction. And now if I put that x minus 3 in the denominator, I'm going to have to put it in the numerator as well. Now let's do the same thing for the second fraction. For the second fraction, we've got an x plus 7 and x minus 3. It looks like we're missing an x minus 8. If the second fraction is going to have everything that the first one has, we're going to need to insert in here a factor of x minus 8. I apologize that that is getting a little tight, so it might be difficult to read, but that is x minus 8. Now we're all ready to go with multiplying. Our denominator is x minus 8, x plus 7, x minus 3. For the numerator, what we're going to do to add is we're going to multiply each of the sets of factors. So we're going to use FOIL to multiply those together. X plus 5 times x minus 3 is going to be x squared plus 5x minus 3x is plus 2x. Again, what I got was a 5x minus 3x. So x squared, first times first, outside times outside, and inside times inside, gives us a negative 3x and a plus 5x. And then the last times last, negative 15. But that 5x and minus 3x combine to 2x. Actually, you know, I'm sorry, I've started to write this over, but I forgot. We already clarified that we've got the common denominator. So what we have here is our first term, our x plus 5 times x minus 3, and now we're going to add that to the x plus 4 times the x minus 3. So if I multiply that x times x, 4 times x minus 8 times x, so 4x minus 8x will give us negative 4x, plus 4 times negative 8 minus 32. So I've FOILed that second one. Let me erase this so that it doesn't confuse what we're doing next. So let me recap. What we did was we FOILed the x plus 5, x minus 3 to get x squared plus 2x minus 15, x plus 4 times x minus 8 to get x squared minus 4x minus 32. Go ahead and pause the video and do that FOIL on your own if you need to. So the next step here is we simplify is going to be to combine the like terms. Now our denominator doesn't change. We just keep this whole thing, the whole denominator is going to stay over the x minus 8, x plus 7, x minus 3. But in our numerator, we have an x squared plus x squared, so that's 2x squared. 2x minus 4x is minus 2x. Minus 15 plus negative 32, negative 47. I'm going to just give that a quick double check. X squared plus x squared is 2x squared, minus 2x, minus 30 plus 10 is 40, 5 plus 2 is 7. So yes, it looks like that is all, in fact, good and ready to go. The last step is to double check that there's nothing that'll factor. And as I look at this 47 appears to be a prime number, or at least I'm not finding any factors that go into the 47. I can tell that neither x minus 8, x plus 7, or x minus 3 are going to be a factor of that numerator. So I know that there's nothing else that simplifies, and I can tell that it's done. Well, I hope that this video of examples helped you. I do want to do, we're getting a little bit long, so if that's all you need, then you could go ahead and stop the video here. But let me just do one more quickly. What I've done off to the side is I've factored the 3n squared minus 30n plus 72, and I factored the 5n squared minus 20n, and I've rewritten both of the fractions. Now what I do is when I write this, I write them with an exaggerated fraction bar, so I make that fraction bar longer, and I write it in factored form. So rather than copy this problem down, what I do is I write it with an exaggerated long fraction bar, and I factor that denominator. As you compare the two denominators, if we wanted them to be identical, to be common, then you see that this one needs a 5n, the first one needs a 5n, and we already have the n minus 4. Now this first fraction has everything in its denominator that the second one had. The second one is going to need a 3 and an n minus 6. Once it has a 3 and an n minus 6, it'll have everything that the first fraction has. So we have our common denominator. Our common denominator could be written more simplified as 15n, 5 times 3n, n minus 4, n minus 6. Now there's no need to multiply those out. You want to leave it in its factored form. In the numerator, we have a 4 times 5n is 20n minus 5 times 3 times n minus 6. I'm going to see that as a 15n minus 6, or 15n minus 15 times 6, which gives us 90. I'm going to show you how you don't want to write this. You don't want to write this 20n minus 15n minus 90. That is a common mistake. But notice that this minus here, we're subtracting that whole thing. So we've got to subtract the 15n and subtract the 90. So a better way to do that would be to change this to adding negative 15n plus 90. Or in other words, we're going to distribute a negative. So we get negative 15n plus, sorry about that, 90. But make sure you're not working with a negative 90. And that's almost done. We'll combine these like terms. 20n minus 15n gives us 5n. And it looks like we can factor that. I know sometimes these problems just drag on and on, but you have to notice that this 5n plus 90 has a factor of 5. So we can factor out and reduce. I'm going to write the 15 as a 5 times 3. And then if we go back to reduce, that 5 over 5 is a 1. So we factor the 5 out, and then we reduce it or divide both the top and bottom by 5. So it looks like our final answer is n plus 18 over 3n times n minus 4 times n minus 6. Well, I hope that video helps you just a little bit more, and I'll say that the only way to really get good at this type of a problem is to practice it. So I hope you'll jump into the homework and practice this type of example.